Hello, 12th graders. So we are on our last lesson of the year, which is insane, of 2 years, which is even more crazy. We are wrapping up the idea of the trapezoidal ability to approximate areas underneath a curve. And so what we've done so far is we've talked about, well, we know that the integral is the area underneath the curve. And what we're doing now is we're like, well, what if things are hard, things are difficult, we only have a table, or like this equation is really hard to find the integral of? And what if instead we just approximated this by drawing trapezoids underneath, and to find then the area of each of these trapezoids? And it gets pretty darn close to what that curve actually is. And we talked about, okay, breaking it up into separate sections, doing those composite figures that we've been doing a lot with this area situation underneath the curve. We talked about doing it with slightly more difficult problems, and we talked about, like, drawing these quick little graphs in order to help us understand what's going on. Hopefully, in this process, you started to notice a pattern. You're like, okay, well, I'm doing this, and then I'm doing this, and you're like repeating this process. And mathematicians don't really like to repeat processes because it's inconcise. It's not a concise way to perform a calculation. If you're repeating that calculation over and over again, shouldn't there just be like a rule or like some sort of calculation that you can do that isn't this repeated process? And the answer is yes. Yes, there is a formula. There is a rule that you can use that encompasses everything that we've just done into a specific formula. So I'm going to use my teacher notes really quickly because they're just a little bit more descriptive than what we did together on your notes. So when we found the area of each of these trapezoids, we have this 1/2. We always had a 1/2 being multiplied, right? And then we always multiplied by the height of your trapezoid, which, remember that the height of your trapezoid is the distance between your two bases, which ends up being this, like, what looks like intuitively would be a base, but it's not. It's the height that's between your two bases. And so you had this height that, as long as your intervals were consistently 0.8 apart, you multiplied by 0.8 every single time. So there's consistencies, right? And then you added 7 here, and then you added 6.26. And then we always kept on bringing back that last value. 6.26 was added twice. 4.97 was added twice. 2.72, 1.19, they were all added twice. The only ones that weren't added twice were the very first base of 7 and the very last base of 8, right? Everything else in the middle was added twice in order to get these areas of the trapezoids. So these are all some things that your mathematicians have discovered to be true. And they were like, well, let's turn that into a formula. If there's a repeated pattern, can't we just formulaically describe it to make sure to streamline this process? So here is your formula. The definite integral from a to b of some function that we will call y, and it's a function of x, right? So y is some sort of equation of x, is approximated to b, right? So remember that this trapezoidal rule is not an exact area, it's an approximation of your area. And it is equal to, they've said, okay, there's a half at the beginning of every single thing because that's how you find the area of a trapezoid. So that's a half. And then it's always multiplied by, as long as your intervals are consistent. So let's write that down. As long as intervals are consistent. Even intervals, right? As long as it's always 0.8 distance apart. Because that's what this h relies on. This h relies on that same distance apart for all of your trapezoids. So this is your interval length. Up above, it was 0.8. On previous problems, your interval length was 0.5, right? Everyone was a distance of 0.5 away. And then they were like, okay, well, we added the first base once, right? 7 we added once, and 8 we added once, and everything else we added twice. And that's what goes into the second parentheses. Okay, well, they call it y sub 0 plus y sub n plus, so y sub 0 and y sub n. Y sub 0 is your first base, and y sub n is your last base. So first and last bases. So remember that your bases are the base of your trapezoid, right? So really your first and last heights. I hesitate to say that. Plus, and then everything else in between, all of your bases in between get added twice, right? So then it's plus 2 times, well, the addition of all of your other bases in the middle. So after y sub 0 would be y sub 1, and then y sub 2, and then y sub 3, y sub 4, y sub 5, all the way till you get to not the last base, but the base before the last base, right? So n would be your final base, n minus 1 would just be the base one less than that, the one before your final base. So they just took this pattern of like, well, this is always what happens is we always multiply by a half, by a height, and then we add all these bases, and they just combined that all into one big formula. And that is your trapezoidal rule. So then these guys are your inner bases. Okay, so this is the formula. It's nice to have a formula because it streamlines the process. Do you have to memorize the formula? No, you can just break it up into your composite figures and then add all of those composite figure areas together. Still a viable reason. Formulas in your formula packet, so you always have that with you. And so that's kind of nice that you're like, okay, I need to do the trapezoidal rule, or I need to approximate the area underneath the curve using trapezoids. Well, I can just use this formula that just, I don't have to keep doing all of the separate pieces. Okay, so it says write down, our first example, write down an expression using the trapezoidal rule to estimate the area under the curve from 1 to 3 with intervals of 0.5 units wide. So we're going from 1 to 3 on the x-axis. So if we wanted to kind of quickly visualize this, 1, 2, 3, and we want to have intervals that are 0.5 centimeters or just 0.5 units wide, which means after 1, we would go to 1.5, right? That interval would be a 0.5 distance. And then between 0.5 and 2 would be a 0.5 distance, and then 2 to 2.5, and then from 2.5 to 3, right? So just a really quick, do I understand this visually? A really quick visual, like, okay, if we're going from 1 to 3 on the x-axis and we want to split it up into intervals that are all 0.5, this is what it would look like. So we want to approximate the area, or we're just right now just writing down an expression of the using the trapezoidal rule. So then that would be equal to from 1 to 3, right? The definite integral or the area underneath the curve from 1 to 3 of whatever f of x is, we don't even know, dx, is approximately 1/2, and then we multiply it by the height. Well, remember that our height is the length of that interval, right? So the length of your trapezoid, because this would be like something that looks like this, and then maybe it's something that looks like this, and your height is going to be that guy, and it's the length of your interval. And we know that all of the intervals are 0.5, so as long as there is a consistent, as long as the intervals are consistent, as long as it's a consistent interval, totally works. So that's what we put in, is the 0.5 is the length of the interval for h. And then we've got the first and the last bases. Now, we don't know what these are yet, but we know that what we'll be adding in is the base length, the first base length and the last base length. We know that that base length is really the y distance of this point, right? So if we're talking about this point right here, as we've talked about above here, right, that y value is that height of that base. So what we would do in order to find that out is we would have to plug in whatever the y value that's associated with an x value of 1. In other words, we would need to find, if we're talking about f of x, we would need to find f of 1, right? F of 1 would be that y value, and that would be our first base. And then we would need to add in our last base. Well, our last base occurs at an x value of 3. So we would do f of 3. And then it's 2 times all of the bases in between. Well, we've done f1, f3. We have 3 bases left in between that we need to add. So our first base would be f of 1.5 plus f of 2 would be our next base. plus f of 2.5. And those are all the bases in between. Notice that 2.5 would be your n minus 1, right? It's one base less than your last base. And it's all just building off of this pattern that we saw in our previous examples of like, hey, we only add the first and the last base once, everything else gets added twice. We're always multiplying by a half, we're always multiplying by that height. So it's just taking all of that pattern and creating something useful with it. And that's it. We just needed to write down an expression. We don't have the equation yet. Part B gives us the equation, but we don't have the equation yet. And it's just, this is what you would need to do. This would be the first step in order to calculate the rest of these areas. So it says, hey, the value A is equal to the area under the curve of f of x being equal to this, referencing this f of x, right? So we've just written down an expression that represents this area. Well, f of x now is x squared plus 1. When estimating using the trapezoidal rule, find the value of A to 4 significant figures on this interval. So pretty much we've done everything up to this point. This is our f of x up here. We are going from 1 to 3, same as what we wrote here. And so pretty much all that we're doing right now is just fulfilling the rest of this expression by finding out what is f of 1. What happens, what is the value when we plug in 1 into f of x? So A is that area under the curve, and it is approximately 1/2 times that interval length, which is 0.5, times, and then now we need to do f of 1. Well, f of 1, we plug 1 in for x squared, so that's going to be 1 plus 1 is 2. Then we plug in f of 3. 3 squared is 9, plus 1 is 10. So we do f sub 1 is 2, or sorry, f of 1 is 2, f of 3 is 10. We add those guys together. Plus 2 times, and then 1.5. F of 1.5, 1.5 squared is 2.25, plus 1 is 3.25. Then 2, f of 2 would be 4 plus 1, which is 5. 2.5 squared is 6.25. 6.25 plus 1 is 7.25. Or you can just use your calculator. So this is how you use the trapezoidal rule. You first need to figure out, okay, what's my first and my last base? What are all the bases in between? What is my interval length? And you just need to plug it into the appropriate places in the formula. There's a lot of pieces in this formula, and the formula looks crazy. It looks crazy, right? But as long as you know what each of these pieces mean, it's pretty straightforward. I would like for you to just go ahead and calculate this. Put this into your calculator, and you got this. I would add all of these guys, multiply by 2, then add 12, then multiply by 0.5, and again by 0.5, and you get a total of 10.75 units squared. All approximate, because we are still just approximating the area underneath the curve. This isn't exactly the area underneath the curve. This is a way to guess what to get as close of a guess as possible for the area underneath.